Thanks, everyone, for your time. Thanks, FINOS, for that awesome organization. And thanks for the opportunity to really speak about open source technologies. Obviously, otherwise that would be probably the wrong forum. But open source technologies in the context of accelerating trade cycles, and especially relevant as we are moving towards T1 settlement. So with me today, the clicker doesn't work. With me today, Ashley Traynor, our solution architect for financial services at Databricks. Me, Antoine, technical director for financial services at Databricks. And Ashley and I are absolutely thrilled to co-host this session with Stephen Goldbaum and Ephrim Stanley, respectively a distinguished engineer at Morgan Stanley and a technology fellow at Goldman Sachs, to talk about legend, Morphir, how those different open source initiatives can coexist, can be integrated and harmonized when coupled with Databricks backend. So we have a packed agenda, so let's get started right away with that quote. Or probably more of a statement than a quote, but something that we've seen in Wall Street back in 2015 when the industry was moving from T3 to T2. So 2 days to close and settle all those trades as a way to minimize that risk of those trades failing, and therefore minimize all those margin calls, right? So time equals risk, reducing that time makes sense. But that was back in 2015, built specifically for a period of high market volatility. What have we seen since 2015? We've seen a Brexit, we've seen geopolitical tensions, we've seen a global pandemic, and with it a frenzy for retail investment, from meme stock, from Reddit posts. We've seen an explosion of data. And that explosion of data really pushed our trading systems to the edges, really exposed clear limitation of what our back offices are able to cope, to scale, to adapt to those changing conditions. But volatile market means that we need to bring that time even further down to 1 day. So initially suggested by the DTCC, now en route for being enforced by mid-2024. And that gives us, practitioners, just 1 year to design, to implement, to test, not 1 or 2 or 3 systems, but an entire ecosystem shared with all market participants. So from the buy side, the sell side, the custodians, the clearing houses, somehow all those different services and systems will need to work in harmony. The challenge we see is that back office are plagued with legacy technologies, plagued with silos, data silos, people silos, across asset classes, across regions, and plagued with manual processes. I wouldn't be surprised if today I hear some analysts are physically running from one mainframe to another with a floppy disk, right? Or sending that via FedEx, or recoding an entire Excel spreadsheet on a database every single day. So the way we're going to achieve T1 as an ecosystem, as an environment, is through automation. And automation would be kind of naive to think everybody will be using the same technology and the same proprietary model. Automation will need to be about standard, and open source is key. So somehow it's aligned with those key values of open source technologies, creating new standards that enable that interoperability across different systems, that may be using different technologies, but harmonized around those different standards, and driving that collaboration. So Legend and Morphir are great examples to enable that interoperability, data as a contract, models as a contract, logic as a contract that can be interpreted across different systems. And before I hand over to Stephen to talk about Morphir, just want to stress really the importance of having that right data culture. We've seen that over and over, whether it's data-driven, whether it's about cloud, whether it's about open source, organizations that went through that kind of behavioral shift, that transition in terms of a data culture, win. Why? Because they can adapt to all those changing conditions much faster than anyone else. And to put that in perspective of T1, when DTCC estimates that the margin calls can be reduced by 40% by moving to T+1 day, that's billions of dollars that could be reinvested somewhere else, assuming we can connect the dots, assuming we can cut the middleman, kill those manual processes, and streamline that entire process throughout that entire trade life cycle. So let me hand over to Stephen to talk about Morphir. We will be looking at an example that is not necessarily about T1 settlement, but you will be looking at this through the context of regulatory reporting. But the principle is that all those technologies are generic and can be adapted. And we can use that for LCR calculation today. The same can be used for trade settlement tomorrow. All those different technologies can be interoperated across different systems. So without further ado, over to you, Stephen. And yeah, thanks.
Okay, so yes, so we're here to talk about how we can bring the FINOS ecosystem together to do new and interesting things. And what is more interesting than regulations, and what better regulation is there than the liquidity coverage ratio, right? And so the liquidity, otherwise known as the LCR, because it's a mouthful, is really about categorizing cash flows. So you take all these cash flows and categorize them into groups. And then once you've categorized them, you apply haircuts to those groups. And then you aggregate all that up. And then you apply some math on top of that to eventually come to a single number. That's what the whole thing is. So there's a lot of different kinds of processing there. And excellent, excellent. Thank you. And so one of the things you might ask is, well, how can we implement that? And that's where Morphir comes in. So what we've done is coded the LCR in Morphir. And just to kind of highlight some of the things you can do with that is, with Morphir, you can interact with it, interact with the logic in a non-technical way. So what we're looking at here is a subset of the regulation specifically about assets. And what we're looking at is the section that takes those assets and, based on the attributes of the assets, figures out what group it should be put into. And so one of the questions that you often get as a developer is, the business will come to you and say, why did this particular asset get categorized that way? And instead of having to go dig through code, we can actually give them this tool and say, you know what, you can go and interact with it and find out. And then they can go click on this thing. And this is all generated from the business logic. But they can go in and they can see exactly why we got to certain results the way we did. And on top of that, we can then unit test it. So then we can plug in values into this inputs area and put those into unit tests. So all of that is just a way to make sure that everybody's confident that we got the rules correct. And we do that by having an interactive session with the people who know the rules so that they can go in and understand that what we've implemented and then put in their own test cases to that. So the next thing you might ask is, okay, that's great, but then how do we execute it? Well, what we can do is we can use Morphir's tools to generate into different execution contexts. And so in this example, we're going to generate Spark so that we can execute into the Databricks Lakehouse platform. And by doing that, we're handing off execution to a managed platform. And then the other thing you might ask is, well, how do we integrate that? And the answer to that is, well, we can take the information of the structure of the assets that needs to be handed to this calculation in order for it to run, and we can hand that to an integration technology like Legend. So we can take this is the structure of the asset, by the way. We can take that information and hand it to Legend, and then let Legend pull that data in from on-prem and put it into the Lakehouse for execution. And so that way, we've got the entire ecosystem. Again, this is all open source technologies, and we've got this all working together in a way that provides value to everybody. And with that, I will hand it to Ephrim.
Oops, sorry. Thanks. Hi, everyone. Thanks for having me. My name is Ephrim Stanley. I work for Goldman Sachs. I'm also a contributor on the Legend project. So today, what I want to do is give you an overview for the Legend data platform and walk you through a real demo of building a data access API that we called a Legend service. So Legend is a data modeling and data management platform. And a data model is a systematic way by which you describe the logical shape of data. Now, data models are super important because they allow multiple parties, whether you are users within the same organization or even across multiple organizations, to have the same consistent view of data. Now, what Legend lets us do is access the data that's in different physical databases through the lens of a logical model. And the way we do that is by creating a mapping between the logical shape of data and the physical shape. And using this mapping, Legend can take a logical query, convert it into a physical query, run it against the data, and get you the data back, right? And this is, again, like super important because no matter where your data is, irrespective of how it's laid on disk, you get a consistent view. And today, thanks to our partnership and collaboration and Antoine's personal contribution, like Legend now supports data in Databricks databases using a JDBC connector. So with that, I'm going to have Antoine help me with a live demo. Yeah. So what you're seeing right now is an application that we call Legend Studio, which is a very interactive, rich data modeling environment. You could do many things with Studio, like you could define a data model. You can manage the lifecycle of the data model through its integration with a Git backend, like GitLab, and we can also execute data access queries. But let's just start by looking at a data model. So here we have a very simple data model of an asset, which is modeled as a class with a bunch of attributes. And now we move on to a mapping. So on the left side, we have the logical shape of the data. And then on the right side, we have the physical model, which in this case happens to be a relational model with a database table. And then in the middle, you have all the mapping rules. In the simplest case, you can take an attribute like business line and map it one-to-one with a database table column. In the more complex case, for example, maturity date, you can map it to a SQL join. Now, with this mapping in place, then we move on to what we call a connection or a runtime. So a connection is where data lives. Now, in this case, we're saying our data is in a Databricks cluster, and you can authenticate with one or more supported authentication schemes. Now, with all of this in place, we can then move on to define a service. So let's look at a definition of a service. So the job of a service is to define the data that you want. So in this case, we're saying we want to project certain attributes of the asset class. But to execute this query, we need to map it with the mapping that we just described. And then we also need to point it to where the data is, which in this case is a Databricks cluster. Now, with all this in mind, with all this set up, we'll see the magic happen now when Antoine executes the query.
If that doesn't work, we'll just blame the Wi-Fi here.
Yeah. So what Legend is doing here is taking the logical query, converting it into a SQL query, running it against a database, and giving your data back. Wi-Fi.
Okay. Yeah, maybe the Wi-Fi. But so we're seeing that, so Stephen created almost an input data model for your job, right? So you were expecting data to come in a specific shape, a specific structure, specific schema. You define that schema, Ephrim, as a target class, and we've mapped that physical model, that physical table into this.
That's right.
So that means that if we can pass that data, that information to a Morphir application, the rest becomes seamless. Yes. So I think that really leads to what we wanted to check at what could be that kind of glue in between. How do we pass and integrate all those different open source initiatives and make sure that the schema of one can be fed into the protocol expected by a different service, different systems? And with that, if Ashley, you can elaborate a little bit of the role of Delta Lake and the importance of Delta Lake as an open source technology as we are seeing in financial services.
There we go. Okay. So hey everyone. Oh, I'm too short for this. So my name's Ashley Trainer. I'm a senior solution architect here at Databricks. And before I get into Delta, I first want to just give a little background on Databricks. So Databricks is a data and AI company. We were founded by the creators of the open source tools Spark, Delta, and MLflow. And the Databricks Lakehouse platform really aims to bring the best of a data warehouse with the best of a data lake. So the reliability, the performance, the governance, the strong governance of a warehouse, but with the flexibility and the openness and the machine learning support of a data lake. And today we have over 1,000 customers in financial services who are using the Databricks Lakehouse to power their data use cases. The foundation of the Databricks Lakehouse is Delta Lake. And Delta Lake is an open source table format that brings reliability and performance to data that's directly in your data lake, instead of putting it into a data warehouse. There's over 190 contributors from 70 different organizations. And actually, as of this summer, Databricks announced that all of the Delta Lake APIs were actually going to be open sourced to make sure that no matter who's using Delta and where you're using it, you're getting all of the functionality and performance that comes with Delta Lake. And that includes things like z-ordering and change data capture and dynamic partition dropping, all that kind of stuff. And so when you think about, and one other thing, Databricks also ensured that all things going forward will be open source in Delta Lake. And it's that openness, the assurance that everything's going to be open in Delta, that really makes Delta an integral part of your strategic decisioning when you think about your tech stack in data moving forward. And it's not, let's replace our old technology with Delta, let's bring in this open source tech. It's actually harmonizing the technology that you've decided on by the underpinning of these open source technologies like Delta. So what we're going to demo today, what we're going to hopefully show in a second, if Anton can switch the thing one more time, is bringing legend modeling together from Goldman Sachs and Morphir's transformation of business logic into Spark as an engine to actually tie these two technologies together to actually do LCR. So let's see here. You scroll the other way than me, right? All right. So here we go. So the first thing we want to show, so the model that we saw earlier in Legend, that model has been created into a jar file, which has been added as a dependency to our Databricks Spark cluster. Oh, wonderful. So what you can actually see here is that we have all of the entities of this Legend model available to us in this Databricks notebook that has full access to a Databricks Spark cluster. So we see here the entities, the services, the functions that were predefined. And these are all actually going to be powered by Spark and Delta on the back end. So this will allow us to do things like create data models in Delta tables, execute queries, all powered by Spark. So we'll see here, this is the actual service that we were looking at earlier. And so really simply and programmatically, we can create this Spark data frame called inflows by executing this legend query, the get inflows with buckets. So under the hood, what's happening here is Spark jobs are kicking off. We're reading data from those Delta tables, and we're bringing in this data frame that complies with the input that's required for our Morphir transformations. But we haven't actually had to write any of that as a user. That's all been abstracted away in this legend model. So now we have that data frame. We're going to pass it off to Morphir. So Morphir can actually take that business logic that we saw earlier and transform it into Scala Spark code, right, so that we can run it on a Spark engine. And so that's exactly what's happening here, and we've actually compiled that Spark code into a second jar that we've added to this cluster as well. So with a simple line of code, we're able to transform that initial data frame into our final value calculations here. Again, with no joins, no data sourcing, no understanding the logic, simply just applying this model to the data frame. So now that we have our results, we want to persist this report somewhere. So we actually go ahead and persist it into a Delta table. And that gives us a lot of additional functionality. So one of the things that Delta does really well is gives us full, basically, DML and DDL support on top of what are compressed Parquet files, really. So we're able to do things like evolve this report schema over time. We're able to do things like add access controls on top of this report. And one other thing that's really interesting is Delta has this concept of what we call time travel, which is basically the ability to, every time we update or overwrite or delete this table, we record that transaction as a separate version of this Delta table. So what we see here when we describe this table is this table actually has 3 versions. The most up-to-date version is whatever we wrote last. But if for some reason we need to audit this report as of a different point in time, either because it was updated or maybe it was deleted, we can actually go ahead and query that really simply using either a timestamp or a version number, just like this in SQL. So we can actually see this report here as of December 2nd. You can also query it by the version number itself. The last thing I'll say about putting this report into Delta is it also gives us the ability to use another open source tool called Delta Sharing in order to provide this report out to other users who may need access to this report, but we don't want to actually copy this report to another location or maintain data pipelines to deliver this, potential for data staleness, all this kind of bad stuff that comes with data delivery. So Delta Sharing is another open source tool that Databricks open sourced in 2021. It is an open protocol for data sharing that allows for real-time sharing of even large data sets without ever having to copy it or move it to another location. And the really powerful thing about Delta Sharing and that it's open source is that because it's open source, it can be integrated into all of the tools that you see in your toolkit today. Tools like Spark and Pandas and Power BI and Java and Databricks, of course, all have integrations to Delta Sharing. So without copying this report at all, we're able to create a recipient, create a share, put this table right in that Delta Share, and then grant them access to this data without ever taking it, in this case, out of our S3 bucket.
Thank you. Thank you, Ashley. So this is really great, right? Because first, what we've seen is that full reproducibility aspect of Delta enforcing that reproducibility of your data, but because we version controlled all the Morphir logic, unit tested that logic, and because we can compile and automatically deploy that logic into your underlying environment, and same with Legend, we have all the evidence of the reusability, the reproducibility and audit requirements from a code, from a data model perspective. So we are in full comfortable position to know exactly that report at that specific point in time. But what Ashley just showed is really critical to enable that last mile, that delivery, whether it's from the back office back to the front office, or whether it's from an organization to other organizations elsewhere, regardless of the underlying technology. So you mentioned Excel, which is a good example, right? People are using Excel on a day-to-day basis. And to use that information, usually we will be sending that data over. Someone will be responsible for bringing that data, coding that into a database, and then exporting that to Excel. Here, we're not even transferring that information. We're pointing Excel directly to where your data sits with that specific version that we agreed. So I think that concludes the demo that we wanted to do. Again, coming back to T1 settlements, it's really about automation, and automation means protocols and standards and interoperability of code, of data, of models. So those capabilities are generic enough to adapt to all those different environments and different systems that you may have. So this is what will drive that automation. So we want to thank you all for your time today. If you have any question, please feel free to visit us downstairs at the booth. We'll answer any question that you may have. If you want more information about all those great initiatives, so I think the best bet is to go at the FINOS website and all the FINOS GitHub organization, where you'll find Legend, you will find Morphir, you will find that Legend Delta contribution that we announced last year as a labs project that is now a top-level FINOS project. And you will see all those different announcements and partnership moving forward on those models and calculations. Thank you very much for your time today. And fantastic panel.